Hello guys, welcome to Tech with Prince James. In this channel, I explain artificial intelligence and machine learning jargon through storytelling. Today I'm looking like a pretty lecturer, so you know that the class today is going to bang. You've probably heard a lot about deep learning recently, especially when you're reading articles about AI breakthroughs like ChatGPT, self-driving cars, facial recognition. It's a term that is in the news. But what is it actually? How does it work? Why is it important? Why is it such a shift in the way machines learn these days? Today, I'm going to talk about everything you need to know about deep learning. This is going to be like a crash course. I'm going to explain what it is, how it works, why it is important, and some challenges that it brings. So, call me best friend. So let's get into business. What is deep learning? Deep learning, also called DL, is a subfield of machine learning that uses neural networks that have multiple layers to learn patterns from large amounts of data. So the deep in the term is because of the multiple layers involved. Instead of being given explicit rules, deep learning models learn from data by themselves, and they discover features or representations that matter, that helps to create a very useful output. So the models that use deep learning technique, they can process raw inputs like images, text, audio, and then perform complex tasks like facial recognition, generating code. So deep learning is what powers most of the AI systems you see today, like ChatGPT, like self-driving car, like Tesla. Let's look at an example so you can understand this deep learning better. So let's say you're trying to train someone to become a world-class painter, Mona Lisa type shit. Deep learning would give the painter thousands of images, thousands of paintings, and then the painter would take his time to go through those images and begin to learn pattern and realize that, oh, when I do this type of strokes, it conveys this type of emotions, or when I paint the sky this color, it makes it more realistic. So he would recognize all those patterns. And so with every layer of understanding, like color, texture, emotions, as he learns more from those data of paintings he has been given, when you give him a blank canvas and say, you know what, show me what you have learned, then he'll be able to now give you at least good enough. Not Mona Lisa, but we're close. So that's how deep learning works. So let's talk about the technical part of how deep learning works. We've seen the story side, but again, let's get deeper into the process. So there's a very long process, but I'm going to try to compress it into 6 steps. Know that these steps, there are a lot of things that goes on behind the scene, but I want to be able to give you a broad picture. So the first part is the input, the raw data. The raw data can be images, it can be videos, it can be text, it can be sound. Now that raw data will be fed into the neural network. So this neural network is kind of modeling our brain, the human brain. When someone touches you, yes, it happens in seconds, but there's a lot of process that happens that makes you to now realize that someone is touching you. Should you slap the person back, or should you just smile? Okay, so that whole process, it goes through layers of traveling to your brain. Then your brain tells you that, somebody else touched you, what do you want to do? That's how the reaction occurs. So that's the same thing that happens here in deep learning. So the raw data passes through multiple layers of neurons. So each neuron that data passes through, we apply a weighted function and activation to be able to learn patterns or features. Hold up, let me explain what weighted functions are. Weight tells the neural network how important a particular input is. So the higher the weight, the more significant that feature is. Bias gives the weighted function more flexibility to fit the data. So the weight and bias and input come together to make up the weighted function that is applied to every data that passes through the different layers of neurons. This weight function only captures the linearity of the data, which does not equate to how real world data is like. That's where the activation function comes in and now introduces non-linearity into the data, and that's how it's able to learn those non-obvious patterns and complex patterns in the data. The third step is forward pass and prediction. This process, the data that has been going through multiple layers keeps going forward, and the neural network now makes prediction based on that data. So let's say the data is images of different animals. We want the neural network to be able to tell us what animal is in an image, so we feed it different images of animals. Now in that prediction process, the model will be like, okay, this is a dog. When it makes that prediction, it now lists its fourth process, loss function. Loss function measures how wrong the model prediction is when you compare it to the actual answer. So when that model predicts that particular image as a dog, is that image a dog? Now let's say that image was a coyote, right? So that means the model is wrong. The model still has more work to do. That means it still has to get to that point where when I give it image of a dog, it can actually tell that that is a dog. It can actually tell that this image is a coyote. It can actually tell this image is a wolf. After this loss function, we get to the back propagation. So when we get to this backward propagation, the model now calculates the gradient and adjusts the weights using gradient descent. Remember that I said weight is just a way of saying this particular feature is more important than this particular feature. So when the neural network has made that mistake of classifying a coyote as a dog, the way to be adjusted using what we call gradient descent. Let's do a recap. First process is the input. Second process is passing the data through different layers of neuron. Third process is computing the weighted function and the activation function. Fourth process is forward pass and prediction. Fifth process is loss function. Final process is back propagation. These processes happen over and over and over again across billions of data points until the model's accuracy improves and now it is able to make the correct prediction. Now let's talk about what deep learning has done. Why is it such a big deal right now? It's because of the many capabilities that it has unlocked. Now, deep learning is what is behind facial recognition. Deep learning is why we are able to generate music, generate stories, generate code. Deep learning is the reason why the medical field can be able to diagnose somebody by examining their x-ray. It's a huge part of our life. Like a lot of things you're using is powered by deep learning techniques. Obviously, there are challenges. I mean, can we escape them in this AI-driven world that we are in right now? So there's the problem of needing massive amounts of data to be able to produce a good output. And because of this large amounts of data that it has to process, the computation power is huge, which is costly. And we have a problem of black box where we don't know how the neural network arrived at this decision. Like I said, even if I try to explain the process in 6 steps, there are a lot that happens, and in that process, you're not able to tell what led to the output. I made a separate video about the black box problem in AI. You should definitely watch it so you can understand better. Despite these challenges, deep learning is a very, very important concept that has changed how AI systems learn and function. So next time you see deep learning somewhere, you should know that it's a subfield of machine learning that uses neural network to learn from large amounts of data. Okay, so we have come to the end of today's video. I hope you've been able to understand what deep learning means. If you like this video, please like, share and subscribe, okay, because I release a new video every week on something in AI and machine learning. Bye.